So you want to know about software testing? Well, you've come to the right place. Whether you're coding, managing a project, or just kind of curious how your favorite apps actually work without crashing every 5 seconds, understanding the basics of testing is absolutely key. Today, we're going to break it all down.
All right, here's the game plan. We're starting with the absolute basics. What even is software testing? Then we're going to bust some big myths that trip a lot of people up. We'll get into what a tester is really trying to do, talk about the huge difference between finding a bug and fixing one, and then zoom out to see where testing fits in the whole quality puzzle, right down to how a tiny mistake can cause a total system meltdown. Okay, first things first. Before we can really dig in, we all need to be on the same page. So what are we actually talking about when we use the term software testing?
And there it is. It's really a two-part mission. The first part is all about discovery. Playing detective and hunting down those pesky defects. The second part is about evaluation. You're putting on your critic hat and judging the overall quality of, well, everything. Not just the code, but the design documents, the user guides, the whole shebang.
So now that we've got that official definition down, let's clear up some confusion. Because honestly, there are some major myths about testing out there that can really mess things up. This is what everybody thinks, right? You just picture someone randomly smashing buttons on a keyboard, just hoping something goes wrong. But no, that's not it at all. The real deal is so much more structured and, frankly, a lot smarter. See, just running the program, what we call execution, that's only one tiny piece of the puzzle. Real software testing is a whole process. It involves a ton of planning, careful management, and reviewing everything along the way. It's a serious engineering discipline, not just messing around.
And this one is a huge one to remember. Dynamic testing is when you're actually running the code. But a ton of value comes from static testing, which is when you review the blueprints, the requirements, the design plans, the code itself, before you ever hit run. Just think about it, right? It's way, way cheaper to find a mistake on an architect's blueprint than it is to tear down a wall after the house has already been built.
Okay, so if it's not just about clicking around and breaking things, what is a tester trying to do? What does a win actually look like for them?
What's so wild here is just how broad these goals are. I mean, yeah, of course, finding defects is number one on the list, but look at all this other stuff. Testers have to make sure the software actually does what the users asked for. They evaluate documents. They give managers the critical info they need to decide if the software is ready to ship. And maybe most importantly, their work builds confidence that this thing is actually good to go.
Now this is a sentence you should probably write down. No software of any real complexity is ever going to be 100% perfect. It's just not going to happen. The real goal of a tester isn't to find every single bug. It's to reduce the risk of a major failure down to a level that everyone is comfortable with. It's all about risk management. Okay, building on that, let's clear up something that trips up so many people. We're talking about the difference between testing and debugging. They sound similar, but trust me, they are two totally different jobs. So here's the simple breakdown. A tester's job is to find the problem and report it. They're the detective showing up at the crime scene and saying, hey, here's what's wrong. Debugging, on the other hand, is the work a developer does. They take that report, they dive into the code to figure out why it's happening, and then they actually fix it. Two very different roles needing two very different sets of skills. And this shows you exactly what that developer's debugging process looks like. After a tester finds a bug, the developer has to, first, make the bug happen again on purpose. Then, they got to figure out the root cause, and only then, after all that analysis, can they actually go in and fix the code. Okay, so we know what testing is, and we know it's not debugging, but where does it live? Let's zoom out and look at the big picture. Let's talk about quality. This is a classic but super important distinction. Think of it this way. Quality control, or QC, is about finding problems in the finished product. It's corrective. It's like an inspector checking a car at the end of the assembly line. Quality assurance, or QA, is about making the process itself better so that problems don't even happen. It's preventive. It's like designing a better assembly line in the first place. And that brings us to the key takeaway. And by the way, this is a super common question on certification exams. Because testing is all about finding defects in the actual product, it is a corrective action. That means testing is a core part of quality control, or QC. And we can never, ever forget that quality doesn't just happen in a vacuum. It's always a balancing act with three things: the project's scope, its time, and its budget.
You want to increase the quality, it's probably going to cost you more time or more money, or you might have to build fewer features. Every single project has to manage this tricky balance.
All right, to wrap things up, let's look at the origin story for every single bug you've ever run into. How does one little human slip-up spiral into your whole app crashing?
It's a chain reaction, really. It always starts with an error. That's just a person making a mistake. Maybe they were tired, maybe they misunderstood something. That error then gets baked into the software as a defect, which is just another word for a fault or a bug. Now, that defect can just sit there harmlessly for a while, but if the code containing it ever gets executed, boom, that's when you get a failure, the thing you actually see, like the error message or the crash. And remember, these defects aren't just hiding in the lines of code. A mistake in the original requirements document, that's a defect. A confusing sentence in the user manual that causes someone to use the software wrong, that's a defect too. Which is exactly why reviewing those documents, static testing, is so incredibly important.
So the next time one of your apps just completely gives up on you, think about that chain of events. Who's to blame? The person who made the initial error? Or the person whose job it was to find that error before it got to you? The truth is, quality is a team sport. It's about everyone, from the very beginning to the very end, working to prevent mistakes and to find the ones that slip through.